Welcome everyone and thank you for being here. My name is Chunping Wu and the co-author is Fu Yun Yu. Both of you are professors from Taiwan today. We are honored to present our research titled Opening Rural Pathways to Computational Thinking and AI, Exploring Motivation Among Economically Disadvantaged Primary Students. Rural students face limited access to enriched learning environments, while Taiwan's One Tablet Per Student initiative provides necessary hardware, the Blue Cube. This alone is insufficient. As our thesis states, hardware alone yields limited impacts without effective engagement. Intrinsic motivation, the red puzzle piece, is the missing link required to bridge the gap effectively. To examine how short-term programs foster engagement, we adopt a dual theoretical lens. We use self-determination theory (SDT) to focus on meeting students' basic psychological needs, autonomy, competence, and relatedness. Complementing this is cultural historical activity theory (CHAT), which provides a structured socio-cultural system framework. Our core concept is that internal psychological needs flourish only when supported by a robust socio-cultural learning system. The research context involves 20 economically disadvantaged 4th to 6th graders from a rural primary school in Penghu County, Taiwan. We conducted an intensive 4-day camp focused on AI and CT literacy. Crucially, while voluntary, we achieved a 100% sign-up rate. This demonstrates a proven appeal to these underserved learners before the curriculum even begins, providing a positive foundation for our analysis. Our pedagogical blueprint focuses on integrating 3 critical components to achieve engaged learning. These are 1. Students' existing cultural capital, specifically marine education. 2. Constructive interaction with emerging technologies like generative AI. And 3. Developing cognitive computational thinking, CT skills. These components are interconnected by the POE, Predict Observation Explanation strategy, which serves as the core instructional method catalyzing this integration. The curriculum architecture guided students from their local ocean experiences to algorithmic thinking. It progressed through 3 phases. First, observation and analysis, where students used AI tools to analyze marine life features. Second, tangible creation, such as creating story scripts about fishermen. Finally, iterative problem solving, where students applied CT to program robots in a digital fishery, demonstrating logical reasoning and debugging. Guided by the purpose of this study, understanding our participants' like rural learners' motivation for participation in this camp on CT and AI, Cultural Historical Activity Theory (CHAT) was adopted as the theoretical framework for instrument development. A total of 22 items ask students to assess the level of importance of the various characteristics, features, designs, and structures of the respective components of CHAT via a 5-point rating scale from 1, not important, to 5. For example, for the community component, 7 items were devised to collect students' views regarding the characteristics of other involved individuals explicitly, the caringness and helpfulness of the teachers, and B, respect for each other's opinions and helpfulness of their group mates. As for data analysis, quantitative data collected from question 1 and question 2 were analyzed by descriptive statistics. Descriptive data collected from question 1 were analyzed using a constant comparison method proposed by Lincoln and Guba. As revealed in the table, for Q number 1, the quantitative data showed that they varied greatly, ranging from all except one participant 92.86% choosing Saving the Polar Bears to 0% choosing Kebby the Robot Tells a Story. Students' explanatory supporting reasons to their selections revealed 3 major themes: fun and interesting, N equals 20. 50% of the responses, for example, the characters and involved props, for example, polar bears are cute, or the game rules of the activities are fun and interesting. Learning and advancing knowledge and slash or strategies, N equals 15, for example, learning facts about the marine life cycle. Knowing what we can do to help alleviate problems of global warming or ocean pollution, mastering strategies to solve adventure games, opportunities to manipulate, create, and be in charge during the process n=11, for example, programming a robot, creating stories/tasks/questions for peers to solve. All designs and features secured an average score of 4.71 on a 5-point Likert scale, with an average of 93.83% of the participants ranging from 85.71% to 100% to be at the high or very high level of importance, for example, 4+5. At the individual aspect/item level, I can learn new knowledge and skills under the objects component, 4.93, ranked first, whereas two aspects/items, I can use technology to create things, under the tools component. There are opportunities for me to make my own decisions, under the rules and division of labor component, 4.86, ranked second. At the component level, tools ranked the highest, followed by objects, and then rules and division of labor, with community ranked the last. Despite their different rankings, the average scores of all four components were similarly high, ranging from 4.69 to 4.79, pointing to their importance in influencing students' decisions on camp involvement. As for question 1, the descriptive data revealed that participants' motivation was drawn from multiple sources. Explicitly, the two aspects of intrinsic motivation, for example, fun and interesting, competencies and knowledge promotion, and being able to control, that is, the autonomy element of SDT of the activity, were highlighted most frequently by the participants. As for question 2, all purposefully incorporated aspects/features of the activity were regarded as having high or very high importance. The results reflect and highlight the following points, factors including A. Individuals interacting with the subjects in the social context, i.e., community, B. Both intrinsic and utility value of the curriculum, that is, objects, C. The technologies introduced, that is, tools, and D. The design of the activities, that is, rules and division of labor, all played a vital role in the subjects' decision-making processes in terms of their future participation in the camp. It reconfirms the essential concept of chat, shifting from focusing merely on individual actions to the interplay of interconnecting factors within a social system. With the tool component ranked first and objects ranked second, it affirms our choice of topics for camp and the importance of the subject's object-oriented nature for understanding human activities. Based on the findings, camp coordinators and designers for rural camps are suggested to note that, while the interestingness and goal to learn of and with emerging technology, that is, tool and object, can draw economically disadvantaged students' involvement and participation, other essential components of equal or more importance cannot be ignored. Positive climate of the community, for example, helpfulness, respect, and open communication within groups, learner-centered, constructive approaches to learning, for example, collaborative projects, hands-on activities, peer tutoring, and student-generated questions, that is, rules and division of labor, that can satisfy learners' psychological needs for autonomy should be addressed, given the usual small class size in rural education settings. Only by addressing students' motivation for participation and engagement can adequate content and designs for AI and CT curricula can be devised. Thank you.